Alright guys, today we're going to talk about multiplying a polynomial times a polynomial. Now last class we focused on a binomial being multiplied by a binomial, which was just two terms times two terms, and we used the process of FOIL. Today we're going to take it a step further and say, what happens if there's no limitations? What happens if we can multiply any kind of polynomial by any kind of polynomial? So on number one, if you'll notice, we have a binomial being multiplied by a trinomial. To do this, we have to make sure that every term in this first polynomial gets distributed through every term in the second polynomial. So the math in itself is not complicated, but what is keeping everything organized to find your final answer. So make sure you follow along with my organizational patterns as well as my math to make sure we're doing this correctly. So first, we're going to start with the first term in my first polynomial, which is this n. And I want to distribute this n through my second polynomial. So if I take n times n squared, that's going to give me n to the third power. Then I'll take n times 5n, and I'm going to get 5n squared. Finally, I'm going to take n times 9, and I'm going to be left with 9n. Now I need to focus on my second term. I need to take my second term here and distribute it through my polynomial. But to keep things nice and organized, I'm going to come down here to the second line. So this first line shows exactly what I got when I multiplied my first term throughout my polynomial. Now my second line is going to be my second term. So 3 times n squared gives me 3n squared. 3 times 5n gives me 15n. And 3 times 9 gives me 27. Now, once you've distributed your last polynomial through, or your last term of your first polynomial, that means you're done. If you'll notice here, I have 1, 2, 3, 4, 5, 6 terms. Well, that makes sense if you think about it, because I'm multiplying 2 terms times 3 terms, and that gives me a result of 6 terms. Finally, all I have to do is combine my like terms. So I'm going to go through in order. My first term here is n to the third. So I'm going to look through, and I don't have any additional n to the third. So I'll bring it down and cross it out. My next term here is 5n squared. So let's look through to see if we have any other n squareds. We have a 3n squared right here, and it looks like that's it. So I can take the 5n squared and 3n squared, and I'm going to get 8n squared. Next I have a 9n. If I look through, I have a 15n right here, and I can add those together and get 24n. And all that leaves me with is plus 27. Finally, before you move on, you need to double check that your answer is in standard form. So n cubed, 8n squared, 24n plus 27. That's a degree of 3, 2, 1, and 0, so we are good to go. Let's try it again on number 2. Again, I have a binomial being multiplied by a trinomial. So I need to start by distributing this first term throughout my polynomial. So y times 5y squared is going to give me 5y to the third. Y times y gives me y squared, and y times negative 4 gives me negative 4y. Now we need to distribute my second term throughout my polynomial. But take note, my second term is negative 2. The sign in front of it needs to go along with it. So negative 2 times 5y squared is negative 10y squared. Negative 2 times y gives me negative 2y, and negative 2 times negative 4 gives me a positive 8. Now again, I took 2 terms and multiplied them by 3 terms, so I should end up with 6 terms. So I'm good. Now let's combine my like terms. First, I have a 5y to the third power. I don't see any other y to the thirds, so I can bring it down and cross it out. Next, I have a y squared. I also have a negative 10y squared down here, but no others, so I can combine these two. Be careful, because I'm adding a positive 1 to a negative 10, so that'll leave me with a negative 9y squared. Cross them out. Next, I have a negative 4y, and down here I have a negative 2y, but no others. So a negative 4 and a negative 2 gives me a negative 6y. And then finally, I'm left with a positive 8 that I can add on to the end. Let's double check again that my answer is in standard form. Degree of 3, 2, 1, and 0. So we're okay. Now on number 3, we have a trinomial being multiplied by a trinomial. The process itself is going to be the same. I need to take every term in my first polynomial and distribute it through my second polynomial. But instead of like number 1 and number 2, where we were taking 2 terms times 3 terms to get 6 terms, we're going to be taking 3 terms times 3 terms. So we should end up with 9 terms before we combine like terms. So let's see what I get. X squared times 4x squared gives me 4x to the 4th. X squared times negative 8x gives me negative 8x to the 3rd. And x squared times 1 gives me x squared. Next, I have 2x that I'm going to distribute through. So 2x times 4x squared gives me 8x to the 3rd. 2x times negative 8x gives me negative 16x squared. And 2x times 1 gives me a positive 2x. Next, we're going to take the last term, which is 3, and distribute it through. So 3 times 4x squared gives me 12x squared. 3 times negative 8x gives me negative 24x. And 3 times 1 gives me 3. Now again, we should have 9 terms, 3 times 3. So let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let's go through and combine our like terms. So my first term that I see here is 4x to the 4th. So if I look through, I don't see any other x to the 4ths to combine it with, so I can just bring it down and cross it out. Next, I see a negative 8x to the 3rd. I also have a positive 8x to the 3rd on the second row, but I don't see any others. So when I combine them, a negative 8x and a positive 8x cancel out, so I don't need to put anything on my line. Next, I have a positive x squared. On my second row, I have a negative 16x squared. And on my third row, I have a 12x squared, which is kind of cool because they go like diagonal. But those are all of the x squareds that I can combine together. So if I take it a step at a time, let's start with 1 and negative 16. 1 and negative 16 gives me negative 15x squared, plus 12 gives me a negative 3x squared, and I can cross all 3 of those terms out. Next, I see a positive 2x, and on the last row there's a negative 24x that I can combine that with. Negative 24 and positive 2 gives me a negative 22x. And then finally, I see a positive 3 down here that I can add on. Let's see if it's in standard form. Degree of 4, degree of 2, degree of 1, and degree of 0. Remember, even though it's missing that degree of 3, it's still in reverse numerical order, so it's okay. Let's go to number 4. On number 4, again, I'm taking a trinomial times a trinomial, so I should have 9 terms before I simplify. So 5m times m gives me 5m squared. 5m times negative 6x has 2 different variables. So let's start with the coefficients. 5 times negative 6 gives me negative 30. And m times x needs to be in alphabetical order. So the m needs to go first and the x needs to go second. And then 5m times negative 8 gives me negative 40m. Now let's go to my second term. When I distribute my x, I start off with an x times an m. Now remember, alphabetical order. So the m needs to go first, the x needs to go second. X times negative 6x gives me a negative 6x squared. And x times negative 8 gives me a negative 8x. Finally, I need to distribute my negative 1. So negative 1 times m gives me a negative m. Negative 1 times negative 6x gives me a positive 6x. And negative 1 times negative 8 gives me a positive 8. Now let's see if I ended up with 9 terms. 3 in my first row, 3 in my second, 3 in my third. So I'm good. Now let's combine like terms. My first term is a 5m squared. I don't see any other m squareds in my problem, so I can just bring it down and cross it out. My next term that I see is a negative 30mx, and to combine it with other like terms, it has to have both an m and an x raised to the first power. In the second row, I have a 1mx, but that's all. So if I take a negative 30 and a positive 1, that's going to give me a negative 29 mx, and I can cross those off. Next, I have a negative 40 m to the first. I don't see any other m to the first in the second row, but I do have one in the first row. Now pay attention, they do have the same signs, so negative 40 and negative 1 give me negative 41m, which I can cross off now. Then I have a negative 6x squared. I don't see any other x squared, so I can bring it down and cross it off. Next I have a negative 8x, which I can combine with a positive 6x to give me a negative 2x. And then finally I can bring down my plus 8. Now last step, let's go through and make sure this is in standard form. My first term has a degree of 2. My second term has two variables, so I add their exponents, 1 and 1. So degree of 2 on the first one, degree of 2 on the second one, degree of 1 on my third one, so we're doing good so far, 2, 2, 1. Then my fourth term goes back up to a degree of 2, which is not okay. Let's keep going and see what else I have. Fifth term has a degree of 1, sixth term has a degree of 0. So it looks like everything's okay except for these two terms. It looks like I need to switch these two terms around. I don't have to rewrite my entire equation. I can just erase and rewrite those two terms. So instead of negative 41m minus 6x squared, let's make it negative 6x squared minus 41m. Now that has a degree of 2 and a degree of 1, and now it's in standard form. So be careful with your answers. On number 5, if you'll notice, we have a binomial times a binomial times a binomial. So this is very important that you follow the order of operations. The order of operations states that when you multiply terms together, you need to go in order from left to right, which means that I need to start by just multiplying these two binomials together. Now remember, when you multiply binomials together, you need a FOIL, which stands for first, outside, inside, last. So my first two terms give me x squared. Outside gives me 3x. Inside gives me 8x. And last gives me 24. Now, before we proceed, we need to make sure we combine like terms and simplify this. That gives me x squared plus 11x plus 24. So when I FOILed these two binomials, I ended up with x squared plus 11x plus 24. But I'm not done. That's not all I can do. I still need to handle this guy. So after I've simplified it, I'm going to bring down that x minus 2 and multiply my trinomial now times my binomial. Now pay attention, we have 3 terms being multiplied by 2 terms, so I should end up with 6 terms. Let's see what I get. I'm going to start with this x squared and distribute it through my binomial. So x squared times x gives me x to the third, and x squared times negative 2 gives me negative 2x squared. Next, I have 11x times x, which gives me 11x squared, and 11x times negative 2, which gives me negative 22x. And then finally, I have 24 times x, which is 24x, and 24 times negative 2, which is negative 48. Now, let's go through and combine like terms. My first term is x to the third, which I don't see any other x to the thirds, so I can bring it down and cross it out. Next, I have a negative 2x squared. That can combine with the 11x squared to become a 9x squared. And negative 22x can combine with 24x to give me a 2x. And then I can bring down negative 48. That leaves me with x to the third plus 9x squared plus 2x minus 48. Now let's double check. Degree of 3, 2, 1, and 0. On number 6, if you'll notice, we have different degrees and a couple of different variables, but it's still okay because we're still going to follow the same process. So let's go through and distribute my first term. When I distribute x to the fourth times x squared, I get x to the sixth. X to the fourth times 3y gives me 3x to the fourth y, and x to the fourth times negative 6x gives me negative 6x to the fifth. My second term, negative 6y, being distributed, gives me a result of negative 6y times x squared, which gives me negative 6x squared y, because it needs to be in alphabetical order. Negative 6 times 3y gives me negative 18y squared, and negative 6y times negative 6x gives me positive 36xy. Now let's go through and combine our like terms. First, I have an x to the 6th. If I look through, there are no additional x to the 6's, so I'm going to bring it down and cross it out. Next, I have a 3x to the 4th y, but I don't see any other x to the 4th y's, so again, I'm going to bring it down and cross it out. Next is an x to the 5th, and again, I don't have any other x to the 5th, so bring it down and cross it out. xy, or x squared y, looks like it's on its own as well, followed by y squared and 36xy. So if you'll notice on this problem, we didn't have any like terms, and that's okay. Sometimes that's going to happen. Just be careful to pay attention and make sure you didn't miss anything. Now let's double check our standard form before we move on. First term has a degree of 6. Second term of 4 and 1 has a degree of 5. Third term is 5. Fourth term, 2 and 1 is 3. Fifth term is 2. Sixth term is 1 and 1, which is 2. So 6, 5, 5, 3, 2, 2. We're good to go. On number 7, I have a binomial being multiplied by a trinomial. Go ahead, pause the video, and try that one on your own. Now, when I distributed my first term through, I ended up with x to the 4th plus 6x to the 3rd plus 9x squared. My second term got me negative x squared minus 6x minus 9. Then I combined like terms, but my only like terms were 9x squared and negative 1x squared, so I ended up with x to the 4th plus 6x cubed plus 8x squared plus minus 6x minus 9. Again, I'd like you to pause the video and try number 8 on your own. So when you distribute your first term, you should get 6e cubed plus 12e squared minus 18e, and your second term gets you 12e squared plus 24e minus 36. Now, when you're combining like terms, even though these variables are weird, it's okay because they can still be variables. You should end up with 6e cubed plus 24e squared plus 6e minus 36. On number 9, we have a trinomial being multiplied by a trinomial. So remember, 3 terms times 3 terms should get you a result of 9 terms. I want you to pause the video again and try this one on your own. So when you distributed your first term, you should have gotten 2y to the 4th minus 2y to the 3rd plus 4y squared. Your second term gets you 3y cubed minus 3y squared plus 6y, and your third term gets you 4y squared minus 4y plus 8. Then when you combine your like terms, you hopefully found that there were 2 different terms with y cubed, 3 different terms with y squared, and 2 different terms with just y. So that leaves you with 2y to the 4th plus y cubed plus 5y squared plus 2y plus 8. We're going to skip number 10 and go straight to number 11. On number 11 it says, use the picture of the box to the right. Write a non-expanded expression for the volume of the box. Now what they mean by non-expanded is it looks like this. We haven't multiplied it together and simplified it out. So the formula for volume of a box is length times width times height. Well, they tell me that the length is 2x plus 1, the width is x plus 1, and the height is x plus 3. So I can substitute those in and say that I get 2x plus 1 times x plus 1 times x plus 3. And that is the non-expanded expression for the volume of the box. Now on part B, they want me to expand this expression, and that means they want me to simplify it out. So remember, when you're multiplying a binomial by a binomial by a binomial, you need to start with just your first 2 binomials and FOIL them. So we'll get first, which is 2x squared, outside, which is 2x, inside, which is x, and last, which is 1. Then you can simplify by combining like terms, and we get 2x squared plus 3x plus 1. After you have simplified that, bring down your third binomial, that x plus 3, and distribute your first polynomial throughout it. So 2x squared times x gives me 2x to the 3rd power. 2x squared times 3 gives me 6x squared. My second term, 3x times x, gives me 3x squared. And 3x times 3 gives me 9x. My third term, 1 times x, is just x, and 1 times 3 is 3. Now I can combine my like terms and we'll be done. So let's start with my first term, x to the third. That's the only x to the third, so I bring down that 2x to the third and cross it out. Then I have a 6x squared, which I can put with a 3x squared, and I get 9x squared. And then I have a 9x, which I can put with an x to get 10x. And finally, I'm just left with 3. And I'm left with 2x cubed plus 9x squared plus 10x plus 3. One more thing, since this is the volume of a box, we need to group it and put a label of units cubed.